All right, guys, so welcome back. This is our lesson number 12, where we're talking about the fundamental theorem of calculus, and we're going to start talking about now the fundamental theorem of calculus part 2. This is probably going to be the shortest video that I do all year because it is one of the most straightforward derivative functions that you need to do, and we're taking derivatives of integrals is what we're doing for this. This is what the fundamental theorem of calculus part 2 is. It's very straightforward. I will say that there's a common mistake made, but it's really basic. So guys, just think about this for a second. If I give you guys y equals sine of x, right? And then I integrate this. So I integrate sine of x dx. Well, the integration of sine is going to be equal to negative cosine of x. Okay? If I ask you guys to find the derivative, then the derivative of that integration, right? So the derivative of the integration of sine of x dx, we're going to actually, which again is the derivative of negative cosine of x, then we're going to get sine of x back, right? So if you take a derivative of an integral, you should get it back. Now, just like with the chain rule, we do have one stipulation that we have to deal with here. So if I'm going to do this, what I want to do is I want to tell you guys, when we take this derivative of an integral, we take each function, so we take each function and we replace it with our value. So these are always going to be different variables. And then most importantly, we're going to then multiply by the derivative of that function. So the derivative of x is actually equal to 1, which gives us back f of x. This is a really straightforward one. Well, what happens if we have a function? What if we're integrating from some number a to a function? Well, we're going to plug in the function here, and then we're going to have to multiply by the derivative of that function. So you're always going to multiply by the derivative of this. This is why, ladies and gentlemen, if you were going to plug a constant in, if you're going to plug a constant here, when you multiply by the derivative of the constant, that's just 0. So that's why constants, you can actually just pretend like they don't even exist. Okay, so let's actually show you some really basic examples. If that didn't make a lot of sense to you, it's definitely going to in a second, I promise. So for question number 1, I'm giving you a function, g of x, and I'm giving you that function is an integral from 0 to x of this function right here. So I'm asking you to find this derivative. The first thing that you're going to do is you're going to take this x and you're going to replace it everywhere you see a t, not the dt part, just the function. We're just looking at the function right now. This is just part of the, the width of the rectangle. So we're going to plug in here. So we're going to get that g prime of x is going to be equal to that function, but instead of a t, I'm going to go ahead and I'm going to place an x there. And then I'm going to multiply by the derivative. And I always do this, when I bring the arrow down, I always tell students, find the derivative of this, which is 1. I put that there. I'm going to multiply by 1. And just like I said before, then you're going to subtract. It's kind of like the fundamental theorem. Now we're going to take 0 and we're going to plug it in here, right? So we get the square root of 1 plus sine of 0 squared. But this is why, again, constants will not matter, because if I plug in 0, then I find the derivative of 0. Well, the derivative of 0 is just 0. This is going to go away. So our answer for this problem is simply going to be the square root of 1 plus x squared. 1 plus sine of x squared. This is a classic example where you get back what you start with, just like the sine example that I showed you guys up here. If I look at example number 2, you literally take the x and you move it down here. So f prime of x is going to be sine of x, because again, we're integrating, right? We're taking the derivative of an integral. That's really, I got to stress that. This only works when you're taking a derivative of an integral. So we're going to take sine, we're going to replace the t with x. We're going to multiply by the derivative of this function, which is 1. And then again, because it's a constant, we don't care. So this answer is still going to be sine. And I just did this one. I just showed you guys that example on the top. So let's get a little bit more complicated, but it really doesn't get very much more complicated than this. So these last 4 are just kind of like what you need to know. Now, I will tell you guys that there's a lot of stuff I'm going to teach you this year. So sometimes students do make silly mistakes and forget to multiply by the derivative. But what we're going to do here is we're going to take our function and we're going to plug it in to our function here, right? So we're going to take 3x to the 5th and plug it into cosine of t, and it's going to be cosine of 3x to the 5th. And then I always tell students to go ahead and multiply. As soon as I have them, I always have students, especially in my AB class, I say circle it, draw it down, and then just go ahead and write the derivative now. Because always do that, because this is the one step that students do forget to do when they do these problems. So you're going to plug this in to t. And if this had been a t squared, which we'll get to in a second with this one, you would square it, all right? You do your application for it, and then you're going to multiply by the derivative of what you plug in here. And again, ladies and gentlemen, I do not need to worry about the -1, because if I plug in -1, it would be minus. I still want you guys to know it's still f of b minus f of a. So it's still part of the fundamental theorem of calculus. So then we do the bottom part, but when we multiply by constant, again, it's going to be 0. So this answer, so I don't even know why we need all this room, this answer is going to be 15x squared times cosine of 3x to the 5th. Okay? So that one's a little too easy. So let's look at this one. So this one I like a lot better because we do have actually two functions. There's no constant. So you actually can fully see this, this actual, how to do it. So the derivative of f of x. So this is another way of writing f prime of x, right? The derivative of f of x is f prime of x. So again, we're taking the derivative of an integral. So the first thing we're going to do is going to take our top part and we're going to move it down. And again, I'm going to go ahead and write down that there's a 2x here. That's the derivative of x squared. So I'm going to go ahead and rewrite my function. I'm going to do 1 plus, and then I'm going to do x squared. And sometimes I will tell you guys, you always are plugging this in. That's why I have this sort of here. Don't put the 2x in here. We're taking this x squared and plugging it in here. And we're going to raise it to the 4th. And then we're going to multiply by 2x. And then we're going to subtract, because again, f of b minus f of a is really what this is. So now we're going to take x and we're going to throw it into our function. So it's going to be 1 plus x to the 4th. And then we're going to multiply by the derivative of x, where the derivative of x is 1. And so this is the actual answer that you guys will see for this problem. And so if we simplify it, because they do simplify it. So and by that, what I mean by this is they put the 2x in the front. And they are going to do this as 1 plus x to the 8th. So you will be surprised that some students think this is x to the 6th. So just be careful with your exponent rules. This is x to the 8th. So this is what you would see as the multiple choice part of your function. They're not going to do anything with the radicals and stuff like that. And that's a 4. All right, that's as hard as it gets, pretty much, ladies and gentlemen. That's as hard as it's going to get. I mean, it's pretty, like I said, pretty straightforward with these problems. Again, for question number 5, you plug this in, right? You plug it in right here, so you're going to get sine cubed. So f prime of x is going to be equal to sine cubed. You're going to plug in t for x squared, and then you're going to, I always like to do that, so I know that's my theta. It's always nice to do that. And I'm going to multiply by the derivative of x squared, which is going to be equal to 2x. So this derivative is simply going to be 2x sine of the cubed of x squared. And it doesn't matter, like, this is how you would see it on a multiple choice question. This is very rarely an actual FRQ. What happens if the x is in the bottom? It doesn't matter. You can do two things for this question. There's two ways you can solve the problem. The first way is you can use the rule that we've been talking about many times before. And I'm going to show you guys both ways here. So you can go ahead and say, and this is, by the way, still f of x. Let's keep the integrity of our problem, right? So f of x is equal to this expression. So we can go ahead and pull out a negative. When we pull out a negative, we flip-flop x and 5. And so we're going to do what we've done before. We're going to take the x. We're going to plug it into our t. And so we're going to get negative. Leave the negative outside for a second. We're going to do 1 over x squared. We're going to multiply by the derivative of x, which is 1. And again, because there's a constant, ladies and gentlemen, it's just going to be minus 0, right? It's going to be 1 over 5 times 0. And so this answer is going to be equal to negative 1 over x squared. So that's one way you could do the problem. Okay. The second way is to not even do the identity. Just like we did with the fundamental theorem of calculus in the previous video, we can just go ahead and say, all right, let's do this. Let's go ahead and find the first derivative. It's okay, let's plug in 5. And just do it. Okay, so we plug in 5, we get 1/5. And we're going to multiply by the derivative of 5, which is 0. Okay, so great. There you go for that one. Minus, now look at how I'm writing it here. Minus, now we do the same thing here. We're going to take the x and plug it in. So it's going to be 1 over x squared times the derivative of x, which is 1. And so that's where the negative comes in now, because it's f of b minus f of a. So it doesn't matter which way you do the problem, you're going to get it right. both ways. Okay, both ways. Because the negative will be either introduced in the expression through the rule, or it's going to be through the f of b minus f of a. So the rest of these are, like I said, pretty straightforward. I mean, I'm going to close this video up here in a second, but just for this last example, we're going to take this x cubed, we're going to plug it in. Just be careful when you do this. It's x cubed to the fourth minus 1. You leave everything alone. You do not have to do, they don't find the derivative of tangent, right? You don't need to do that. And so we're going to get this, and then we're going to multiply. We're going to multiply by the derivative of this, which is going to be 3x squared. So our final answer for this problem is going to be equal to 3x squared times the tangent of x to the 12th minus 1. So this answer is going to be D. And that's it, ladies and gentlemen. That is the fundamental theorem of calculus part 2. So that's going to be the end of the video. I hope that makes sense to everyone, and I'll see you guys in the next lesson.